We are going to do one more type of problem with linear programming. We will look at an airline who's trying to decide when to let the airplane fly and when not to. Let's read the story. An airplane has 30 first class seats available and 220 economy class seats. A first class seat costs $240 and an economy class seat costs $120. First class is like twice as much, right? It's a major difference. A flight will be canceled if the money taken for the seats is less than $28,800. In that case, if it doesn't bring in that amount of money at least, then the costs are probably too high, so they won't let it fly. Let X equal the number of first class seats sold and Y equal the number of economy class seats sold. Thank you for telling us what X and Y are going to equal. That helps us a little bit. So these are variables. We don't know yet. We want to make a system of equations where X and Y are variables and we can plug in the actual numbers and figure out, should this flight fly or not? Write down 3 inequalities in X and Y. Let's see. X is the number of first class seats, right? Oh, right. Here, this is our first bit of information. The airplane has 30 first class seats available. So we can only sell 30 first class tickets, right? So X, the number of first class seats, can be 30 maximum, right? It can be less, but the maximum is 30. So the number of first class seats has to be equal to 30 or smaller, less than 30, right? Otherwise, we've sold seats that the airplane doesn't even have. Same for economy class seats. There's 220 available, so the number of economy class seats that we sell has to stay below 220 or equal to 220 if we sell all of them. There we go. Then we need a third one. So the information about what the seats cost and what we want the costs to be, at least to 28,800. We're going to put that into one equation. So let's see. Here we're going to add the seats together. And we're going to say that it has to, the total cost or like income for the airline has to be greater than or equal to $28,800, right? We want the costs coming in to be greater than or equal to this amount. Otherwise, the flight is not going to fly. So let's see, what are our X first class seats going to bring in? Each first class seat costs 240. So 240 times the number of seats that we sell, so X, is what that's going to bring in. That's the cost of those seats, or the income for the airline, plus however many economy class seats we sell times what they cost a piece, 120. So 120 times Y, $120 times the number of seats that we sell. That's what the economy class seats are going to bring in. This is our inequality. that is using this information. We can divide, we can simplify this, right? We can, what do you call that? Factorize 120. This is divisible by 120. That's divisible by 120. And that is also divisible by 120, which would give us 2 times x. This divided by 120 is 2x. This divided by 120 is just y, greater than or equal to. This divided by 120 is 240. So let's use this bottom one just because it's simpler to graph and do calculations with. All right, we have our 3 inequalities. Say they ask us to now graph this. I have copied down our 3 equations. X is smaller than or equal to 30, y is smaller than or equal to 220, and 2x plus y is greater than or equal to 240. Let's graph these equations. The red one, x has to be 30 or less. That's going to be easy. Wait a minute. This is x. This is y. X is the number of first class seats. Y is the number of economy class seats sold. All right. If we want x to be 30, that's here. This line represents all the points where x is 30. Voilà. Now if we want x to be smaller than 30, on this side x is greater than 30, so we're going to shade this because it's unwanted. This. Shade, 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 shade. So I can already tell I've made this graph kind of big. I'm not going to use any of this. That's okay. Let's do the orange one. Y has to be smaller than or equal to 220. So this is 200. Every line is worth 10. So 210, 220. I'm going to use a little more of that there. Voila. So the line representing all the points where y equals 220 would be right here. Y has to be smaller than or equal to 220. Y is smaller than 220 here, so up here it's greater than. We don't want it to be greater than 220, so we're going to shade all of this. Now for this equation, let's just write it out. 2x plus y equals 240. That's the line that we're going to draw. Would it look better if we changed it to y equals mx plus c format? This helps us identify the y-intercept, so it's going to cross the y-axis at 240, 220, 230, 240. Here, let's make it purple because it's our purple line. It's going to cross the axis at 240. What else can we do? We could plug in. Let's do that. Let's plug in 120 for x. Let's see what we get. Y equals -2 times 120 plus 240. I actually knew what I was doing. -240 plus 240 is 0. So when x is 120, y is 0. So that's here. That's our x-intercept. Now I'm going to draw my line. Wow. And which side of the line are we going to shade? We can plug in a random number, a random point. I like to plug in 0, 0, see if that is true in the inequality. So 2 times 0 is 0, plus 0 is 0. So 0 is greater than 240. That's not true. So this point, 0, 0, is not included. So we're going to, so that's on this side of the line. So we're going to shade the whole area on this side of the line. Voila. And we're left with this nice little triangle that is white. And these are all the combinations of number of first class seats sold and numbers of economy class seats sold that will be acceptable, that will make this plane fly, right? It doesn't go above this because we only have 220 economy class seats. It doesn't go beyond this red line because we only have 30 first class seats. And it doesn't go under this purple line because if it did, it wouldn't bring in enough money for it to be worth flying the plane. Okay, now if they were to ask us, what is the minimum number of seats to be sold for the flight not to be canceled? So what is the minimum number of seats to be sold? Minimums and maximums are going to be at these vertices, corners of this required region. Let's call this point A. Let's call this C, this A, and this point B. If this was a really nice graph, let's say at point A, we've sold 30 first class seats and 220 economy class, so 250 in total. Point B, we've sold 30 first class, and this is actually 180, yes, which gives 210 in total. Point C, we've sold 10 first class seats and 220 economy class, so that's a total of 230. So the possibility where the plane still flies that has the fewest seats sold is point B, where a total of 210 seats were sold. That does not mean that if we sell at least 210 tickets, the plane will definitely fly. Out of those 210, 30 have to be first class seats. If we sell 210 economy class seats and no first class seats, that would be this point. This is not included. It wouldn't bring in enough money. This option, 210 seats sold, that's the fewest seats sold possible, but 30 of those have to be first class seats. Sorry for making that sound extra complicated, but when they ask us what is the minimum number of seats to be sold for the flight not to be canceled, the answer is 210, but I want to note that 30 of those have to be first class seats, otherwise it's not going to bring in enough money. All right.